I'm Algebra Annie, and I'm here to help you be successful in your algebra class. Some days you just have to create your own sunshine. Sam Sundquist. Our learning target today is I can factor trinomials of the form ax squared plus bx plus c.
And now we're just factoring polynomials. And we're going to start with a warm-up problem. What two numbers can you multiply together and get 16? But when you add those two numbers together, you end up getting negative 10. So this is a warm-up problem to prepare us for our factoring. And how we're going to solve this problem is that we're going to try first to find all the numbers that multiply to give us 16. So first we're going to come up with all the numbers that multiply to give me 16. Well, I needed a positive 16. I know that a positive times a positive will get me a positive, but I also know that a negative times a negative will also get me the positive. So you need to remember both. We always start with 1 first. If we start with 1 and then we go down in a consecutive order, you will never miss a term. So positive 1 times what gives me positive 16? Well, I know that this is 16. A positive 1 times a positive 16 will give me a positive 16. But I know that a negative 1 times a negative 16 will also give me a positive 16. I did my 1s. Now I need to go and I need to do my 2s. 2 times what gives me positive 16? Well, I know 2 times 8 will give me 16. But I know that a negative 2 times a negative 8 will also give me a 16. So now I need to try my 3s. Because I did 1s, now I did 2s, now 3s. 3 times what gives me 16? Well, I'm thinking about it, and I can't think of one, so we need to prove that 3 doesn't have one with our calculator. So here's my calculator. We are trying to test 16, and we're trying to test to see if 3 would go into it. So I'm going to divide by 3. When I divide by 3, I end up getting a decimal. We only work with whole numbers, so 3 does not work. So we're going to come back here, and we're going to cross off 3. We know that 3 does not work. So we did our 1s, we did our 2s, we proved that our 3 does not work. Now we need to try our 4s. 4 times what gives me 16? 4 times 4 gives me 16, but I know a negative 4 times a negative 4 will also give me 16. The minute a number starts to repeat, you know you're done. So right here, it starts to repeat, which means this is the full, complete list of all the ways to multiply together to get 16. But that was only half of our problem. All the ways to multiply to get 16. Now, of these ways, which one would add and give us a negative 10? So now we need to go through every single one of these ways and see who actually adds together to give us a negative 10. So 1 added to this 16 would give me a 17. A negative 1 with a negative 16 would add together to give me a negative 17. 2 and 8 would add together to give me 10. A negative 2 and a negative 8 would add together to give me a negative 10. 4 and 4 add together to give me an 8. Negative 4 and negative 4 add together to give me the negative 8. Which one gave us the negative 10 we needed? Right here, we found the negative 10 that we needed, which means our answer is these two numbers right here. So what two numbers multiply to give me 16, but when you add them, oh, I'm wrong. We needed a negative 10. I circled positive. It was this one, which means that these are the two numbers that we needed. Not this one, not that one. Watch out for your negative signs. So negative 10. So what two numbers multiply to give me 16, but add to give me negative 10? This negative 2 and the negative 8. So my final answer is negative 2 and negative 8 were the numbers that I would multiply together to get a positive 16 and add to get a negative 10. Our next warm-up problem. What two numbers multiply together to give you a negative 18, but when you add them, they gave you 7? So we're going to first come up with all the ways that you would multiply to get the negative 18. So how do you multiply together and get a negative number? That means one of your numbers has to be negative. So let's start with 1. 1 times what gives me the negative 18? Well, it was a negative 18. You told me that only one of my numbers needed to be negative. So here the 18 is negative. Well, what about the option when the 1 was the negative? So there's my 1s. Now I need to test my 2s. 2 times what gives me a negative 18? It's a negative 9. Well, if that was the 9 being negative, I need one when the 2 was negative. I did my 1s. I've done my 2s. Now 3s. 3 times what gives me a negative 18? Negative 6. So if that was when the 6 was negative, I need when the 3 was also negative. ones, twos, threes. Let's go ahead and try our fours. So I'm going to take my calculator because I can't think of one that works. So here's my calculator. I'm testing 18, trying to see if 4 works. So if I get a whole number, it ended up working. 4 didn't work. Well, our next one's going to be 5. So here's 18, divide by 5. Will 5 work? Well, 5 didn't give me a whole number either. All right, 18 divided by 6. 6 worked. All right, so we need to put 6 down. But I know 6 is already on there, so I'm actually starting to repeat now. So that is the end of my list. Now, if these are all the ways to multiply together to get a negative 18, we need to see who of them would add together to give me my 7. So 1 and a negative 18 added to give me a negative 17. A negative 1 and an 18 added together to give me 17. 2 with a negative 9 was a negative 7. Negative 2 with 9, 7. 3 with a negative 6, negative 3. Negative 3 and a 6 was a 3, and that was the end. The others just didn't work. So here's all the multiplies to get negative 18. Of these, who added together to give me my 7? I see the positive 7 right here, which meant the two numbers that I was looking for are right here. My answer is negative 2 and positive 9. Those are the two numbers that multiplied together to get a negative 18 and added to give me my 7. Now, do you remember back in our previous lesson when we did this exact problem? You found a polynomial with 4 terms, and when you had a polynomial with 4 terms, you were able to group it with the first 2 in the first parenthesis, the last 2 in the last parenthesis, remembering whatever sign was in there, it followed that number because this was always a plus sign. And then with each parenthesis, you found the GCF and you pulled out a GCF. You did it to the right as well, found the GCF, pulled out the GCF. The parentheses had to be the same. If they weren't, you had to double check to see what you did wrong. These are very, very close to being the same. These happen to be opposites of one another. So we had to opposite that last half. So when we opposited the last half, positive 1 was a negative 1, positive 3 was a negative 3, negative b turned to a positive b. I now notice that these were the exact same. Negative 3, positive b, positive b. They were the exact same, so I wrote them so they looked the same. Since now they were literally the exact same, you could pull out the exact same, and your leftovers went into your leftover parenthesis. This was the process that we went through when you were given a 4-termed polynomial. Well, today, we're going to give you a trinomial, which means a 3-termed polynomial. We're going to give you a trinomial. You're going to make it be a 4-term so we can do this process. So you basically already know most of what we're going to do today. You just need to figure out what the steps up here were so we could actually get to here so we could do all of this. So we're going to do a step-by-step direction on how you would factor a trinomial. So here is our trinomial. Trinomials are polynomials with 3 terms, and our first term is always an x squared term. A is the coefficient of x squared. The second term is always the x term, where b is the coefficient of x. And we always have a third and final term that has no variable connected to it. It's just a plain old number. It's a constant. So this is our trinomial, and we're going to be factoring problems that look like this. So our problem is to factor this current trinomial. This is the question we're trying to solve. Can we factor this problem? Step 1. If you remember back when you did fractions, it was really hard to work with fractions that were like 12 over 24 or 24 over 48. Those are all the same thing as a half. It's a lot easier to work with half. So the first thing we want to do is see if there's a way to make this an easier problem with smaller numbers to work with. So step number 1 is to try and factor out a GCF. So step number 1, can we simplify this problem by factoring out a GCF? So if I have this problem right here, I am going to be looking at 2x to the second power, 8x, and 6. We're going to look at the list just like we did in all of our other lessons. So prime factorizing 2x squared is 2 times x times x. 8x is 2 times 2 times 2 times x. 6 is 2 times 3. So if I'm looking for the GCF to see if I can by any chance make this problem any simpler, I see that there is a 2 in common in each, so the 2's are going to be removed from my lists, and the 2's are here in my GCF. I'm trying to see if there's anything else in common. There is not. So I did have a GCF. Now what I tell my students to get in the habit of doing, if this is our question, we're going to factor it and I want you to make a giant box where you are always going to put your final answer right here so you don't lose it, and we know where your answer actually is in the end. Now we're going to take out a GCF of a 2. If you took out a GCF of a 2, that means we have a smaller number to work with, smaller problem. So what do we have left over? List 1 has an x times an x, which meant I had an x squared. List 2 had a 2 times x, which means I had a plus 4x. List 3 had a 3, so here's my plus 3. So I factored out my GCF. I've got this new baby problem right here. This is going to be the new problem that we are actually going to solve. Now you cannot forget about this 2 right here. This 2 was a part of the original problem. You cannot forget about him. We cannot forget about him. He's part of the original problem. We're going to work with this new baby problem, but this 2 is still a part of the original. We took him out at the very beginning, so you need to put him right here at the very beginning and not lose him. He is part of our answer. So step 1, can we simplify the problem by factoring out a GCF? And we did. The problem we are actually going to be working with now is this problem right here because we factored out a 2. Now step number 2 is to identify the ABC. Now remember, we're working with a new baby problem. So if this were my new baby problem that we are working with, we need to identify A, we need to identify B, and I need to identify C, remembering that these are the coefficients to our trinomial. So A is the coefficient for x squared. So what number is in front of my x squared? It's a 1. B is the coefficient for x. So B is a positive 4. And C is the lonely number without any letter. It's just the constant. My constant's a positive 3. So I need to identify my ABCs. So step 3 was the purpose of our warm-up. So what are the two numbers that multiply to give you whatever A times C was, but they add to give you what was? So we're going to make the same chart that we did before. So we need to find all the ways that multiply to get A times C. Well, you said A was 1. So if A was 1, and I have to multiply that to C, you said C was 3. 1 times 3 is 3. So I'm going to try and find all the ways to multiply together to get 3. So I know, start with 1. 1 times 3 would give me 3. A positive times a positive give me a positive. But a negative times a negative would also give me the positive. So there's ones. Now try 2. Does 2 work? Proving with my calculator, I know 2 does not work. I did 1s, 2 doesn't work. So now you try 3s. 3s are already here. So we're already repeating. So this is the end of my list. So there's only 2 ways to multiply together to get 3. So of the 2 ways to multiply together to get A times C, which of these actually give me a sum of B? And you said B was 4. So I've got 2 different ways. One of these needs to add up to a positive 4. So 1 and 3 add up to 4. A negative 1 and a negative 3 add up to a negative 4. So I was supposed to find a positive 4. There's my positive 4, which means the 2 numbers that I am looking for are a positive 1 and a positive 3. So step number 3 was try and find what do you multiply to get A times C and who adds up to B. So step number 4 is to rewrite our trinomial, and you're going to do that by breaking the B part into the factor pair that we identified. So the baby problem that we were trying to solve was this baby problem. We want to break the B part. This is the B part. Now how we're going to break that up is using the 2 numbers that you identified back in step 3. If you remember, back in step 3, you identified 1 and 3 as being the 2 numbers that we were going to use. So somehow I need to rewrite this. So x squared stays as x squared. We need to write 4x by using a 1 and a 3. So instead of writing a 4x, that was a positive 1, we're going to add a 1x and we're going to add a 3x. So if I had 1x and I added 3x together, we got a 4x. And this plus 3 is the same. So we didn't really change the problem. 1x plus 3x does actually equal 4x. So we basically kind of uncombined like terms, and we needed specifically the 1 and the 3. And why? It's because it worked on step 3. We located those numbers specifically. And we're almost done. Step 5, our final step, solve by grouping. And you know how to do this. So this is the problem we currently have, and we need to solve by grouping. So if we are going to group, the first two need to go into the first parenthesis. I have to have a plus sign. And then these last two go into the last parenthesis. And then I need to look at one parenthesis at a time. So this parenthesis, I need to have a GCF thought bubble on the side. I need to figure out if there is a GCF that I could pull out. So prime factorization of x squared is x times x. Prime factorization of 1x is 1 times x. So looking for my GCF, I see that there is an x in common in each, so that x comes down here to the list instead. There's nothing else in common. So looking at this first parenthesis, I chose to take out an x, and I'm supposed to have some kind of leftovers. So list 1 had a leftover of an x. List 2 had a leftover of a positive 1. So this GCF thought bubble was me factoring out my first parenthesis, just like we did in our last lesson. The other parenthesis, so here's my GCF thought bubble. I've got a 3x I need to prime factorize and a positive 3. Prime factorizing 3x is 3 times x. Prime factorizing 3 is just 3. So I'm looking for a GCF they have in common. I see they each have a 3, so the 3 is down here in my GCF. There's nothing else in common. So there's my GCF thought bubble. That's a positive 3, which means out of this parenthesis, I am pulling out a positive 3, and I need some kind of leftovers. List 1 had a leftover of an x. List 2 didn't have any leftovers. Every single list has to have a leftover. So there are leftovers here. We just don't see them because they're a bunch of 1s. So here's my plus 1. Now I see that these parentheses are the exact same. So I'm going to pull that exact same parenthesis out, and then these are the leftovers when these parentheses happen to disappear. So I have a positive x and a positive 3. And then this is the answer to the baby problem that we were doing. So we just solved by grouping. Now that's the answer to the baby problem. Remembering the baby problem was not our original question. So if I bring back up the beginning of our problem, so now we have step 1 and 5. So here's the beginning of our other problem. This was the answer to the baby. The 2 was originally pulled out, and then we started working with the baby. So here is the answer to our baby problem. And then we're done. So we have the 2 when we factored out the very beginning, so we had a baby problem, and then we actually factored our baby. So 2 times the parenthesis of x plus 1 times the parenthesis of x plus 3 is our final factored out problem. And you're done. So here's a new problem, factoring out this trinomial. Now how do we shorten it so it doesn't take 2 full pages every single time? So first thing I need you guys to get in the habit of doing is we're going to write our final answer way up here. So step 1 is always to see, is there a GCF that I could actually pull out of this so my numbers are smaller to manage? So my very first thing on the left side, I'm going to see if there is a GCF in common. So here are the 3 terms from my trinomial. Do these 3 terms have a GCF? So prime factorizing 4x squared is 2 times x times x. Prime factorizing 16x is 2 times 2 times 2 times 2 times x. Prime factorizing 15 is 3 times 5. So I'm looking, is there a GCF they have in common? There is nothing they have in common. So my GCF is a 1. So this was my GCF thought bubble. This problem is the smallest that I can work with. So I am actually having to factor this problem then. He's the smallest that I actually have. So step 1 was to find my GCF. Step 2 is to find my ABCs. So I need to find my A. My A is a positive 4. My B is a positive 16. And my C is a positive 15. Now that I know who my ABCs are, I need to come up with the list. Now remembering, we're trying to find all the ways that multiply together to get me my A times C. You said A was 4, and you said C was 15. So 4 times 15 is, calculator, 60. So 4 times 15 is 60, which means I need to come up with all the ways that multiply together to give me 60. So here is my long list. Start with 1. 1 times what gives me 60? 60. Now a positive times a positive gives me a positive. I also know that a negative times a negative will also give me a positive. There's my ones. Now I need my twos. 2 times what gives me 60? 2 times 30. Positive times a positive gives me a positive. A negative times a negative will also give me that positive. There's my ones, my twos. Now I need my threes. 3 times what gives me 60? That would be 20. That's my positives. Now I need my negatives. So ones, twos, threes. Now I need to try fours. 4 times what gives me 60? 4 times 15. If that was my positives, here are my negatives. I did ones, twos, threes, fours. Now I need fives. 5 times what gives me 60? 5 times 12. That was my positives. Here are my negatives. So now I need my sixes. 6 times 10. That was my positives. So here are my negatives. I need to try 7. 7 doesn't have anything. So try 8. 8 didn't have anything. Try 9. 9 didn't have anything. The next is a 10, but 10 is written right there, which means I am now repeating. So that means that's the end of my list. So my list was a lot longer than I thought it was going to be. These are all the ways to multiply together and get 60. Now one of these ways needs to give me a sum of B. It means they add together to give me B. We said B was 16. So now I need to go through each and every single one of these and find out what they would actually add to get. So 1 and 60 add together to give me a 61. Negative 1 and negative 60 add together to give me a negative 61. 2 and 30 add together to give me a 32. Negative 2 and a negative 30 add together to give me a negative 32. 3 and 20 add together to give me 23. Negative 3 and negative 20 add together to give me a negative 23. 4 and 15 add to give me 19. Negative 4 and negative 15 add to give me a negative 19. 5 and 12 add to give me 17. Negative 5 and negative 12 add to give me a negative 17. 6 and 10 give me a positive 16. Negative 6 and negative 10 give me a negative 16. I was looking for positive 16. Here is my positive 16, which means that these are the two numbers that I need to use. Now the whole point of all of this over here on the right was so that I knew how to break up this middle part, my x term. So the whole point is to break up this x term. So I still have my 4x squared. I'm going to rewrite 16x. And what numbers am I going to use when I rewrite 16x? I'm going to use this positive 6 and this positive 10. So here's my positive 6x because they're x's, and my positive 10x because they're x's. So I rewrote 16x as 6x plus 10x. And this is a plus 15. The purpose of breaking it up is so that we now have a 4-termed polynomial, because from here we know how to factor by grouping. So having 4, I'm going to group the first 2 in the first parenthesis. I need a plus sign in the middle, and I group the last 2 in the last parenthesis. Now I have my first parenthesis. I need to find the GCF of that parenthesis. So I have my 4x squared, and I have a 6x. Prime factorizing, I have 2 times x times x. Prime factorizing, I have a 2 times a 3 times an x. So looking to see who my GCF is, I see a 2 in each list, so that 2 is now my GCF instead. I see an x in each list, so that x is down here in my GCF instead. They have nothing else in common in their lists, so my GCF is a 2x, which means in this first parenthesis, I'm going to be factoring out a 2x. I need my leftovers though. 2 and x are left over from list 1, that's 2x. List 2 is left over with 3, and so here's my positive 3. So that is the GCF thought bubble for the first parenthesis. Now I need to do the second parenthesis. Usually I do it over here, but I'm out of room. So I'm going to come over here and do it on this side instead. So that was a 10x, and that is a 15. So prime factorizing, 10x is 2 times 5 times x. 15 is 3 times 5. Looking for a GCF. There's a 5 in each list. There's nothing else in each list, so my GCF's a 5. He's positive, so I'm pulling out a positive 5, and then I need some kind of leftovers. List 1 had a leftover of a 2 times x, so there's my 2x. List 2 had a leftover of a 3, so here's my positive 3. So that was the GCF thought bubble to find my second parenthesis. Now I see that my parentheses are the exact same. So I'm going to pull that exact same parenthesis out, and the leftovers left behind when these parentheses disappeared was a 2x and a plus 5. So this is the answer to what is usually the baby problem. But did we actually use a baby problem? We didn't, because the original GCF was a 1. So we did not have a baby problem that we worked with. We worked with the original, which means this is the answer to my original problem, and I'm done factoring.
What did we learn today? I can factor trinomials of the form ax squared plus bx plus c. And I look forward to seeing you tomorrow in class.